Chapter 3, Section 1, Question 1, Ordered Pairs and Quadrants. Now, I happen to know the bogus story about how exactly we got the Cartesian coordinate plane, and it might help you to remember how all this works. So long ago and far away, René Descartes, who was a real dude, he was very sickly, and so a lot of times he was just sitting in his bed, looking up at the ceiling. Descartes, spelled so we don't have the pronunciation on the S at the end, so that means probably French. All right, so he is very sick. He's looking up at his ceiling. His ceiling is tiled with little square tiles, and at this point he's already counted all the tiles on his ceiling, and a fly lands on his ceiling. And he says, if I numbered each of the blocks on my ceiling tiles, I could tell you exactly where that fly is. Hey look, it's his ceiling, we have numbered the blocks. Huzzah, we can tell you exactly where the fly is. And then the fly started walking, and he said, if I numbered those blocks on my ceiling tiles, I could tell you an equation for the path of that fly. Folks, you know when we're going to be graphing lines? That's the path of the fly. That's what we are doing in this chapter. Yay! All right, so it's all his fault. It's not really. All right, ordered pairs are going to be written x first, comma y second, and this is the x-axis, this is the y-axis. Write the ordered pair for each one. Because this is a single point labeled A, I'm going to say that A is written at the ordered pair, counting from the origin, which is the center, 1, 2, 3, 4, 5. In the negative direction, that's -5 in the x, and then 1, 2, 3, 4 in the y. That is where A is. So part A, find me the ordered pair for the point, and then if I were to find B, 1, 2, 3, 4 in the positive direction, and 1, 2 in the positive direction. Point C, 1, 2, 3 in the negative direction, and 1, 2 in the negative direction. And D. Oh, D did not, D went 1 to the right, and then 1, 2, 3, 4 down, 1 to the right, and 4 down. Now, the quadrants. The quadrants, we can go back to Descartes and the Cartesian coordinate plane. So if you draw out the axes, the x-axis and the y-axis, and if you draw your C's this way, going around like this, the Cartesian coordinate plane, this is quadrant 1, 2, 3, and 4. Now, let's say that you don't write your C's that way, so it doesn't help you remember it. When you're graphing something, a lot of times you graph it over time and it shows how something is going up, like hopefully your stocks. If you were to send it back in time, this is the most used quadrant. This is the second most used quadrant. And then they just kept going around this way in counterclockwise fashion. So quadrants 1, 2, 3, and 4. You will have to be knowing about quadrants, like, for a long time. Determine the quadrant. So A is here in quadrant 2. Notice that that is a Roman numeral 2, which is 2 bars, and then you connect them. B is in quadrant 1, so 1 bar, and then the top and bottom. C is in quadrant 3, 1, 2, 3, and then connect them on top and bottom. And then D is in quadrant 4. Quadrant 4, V is 5 in Roman numerals, and 1 before 5 gives you 4. And so you can make lots of jokes about IVs. All right. That's how we do this. This should be a review problem, but just in case, we're going over how to remember x first, y second. They're in alphabetical order. The quadrants, and making sure you have the correct quadrants, and also how to write in Roman numerals. Chapter 3, Section 1, Question 2. Solutions to equations. This is an equation. We have solved those back in chapter 2, but wait, I now have an x and a y, a little harder. So what we've done is I have given you an x and a y, and we're going to plug it in and see if it works. This is x and this is y. Remember from last question, those are in alphabetical order. We're going to plug, work, and answer. Y is 3 minus 3. Some people might say, I already know that that's 0. I want to see you plugging in. 1/2. X is negative 2 minus 2. So I've plugged in, and then the work. I'm going to do groups first. And then I can do my adding and subtracting on this side, and my multiplying on this side. And I notice that 0 does not equal negative 2. So therefore, I will circle no. If it makes you happy to use the does not equal sign, you may use it, but I don't need you to use it. Over here, once again, x and y. I'm going to have you plug in, ooh, it is a quadratic. It has an x squared term in it. So as we're plugging in, y is 3, x is negative 2. Remember, you have to have the parentheses around that from back in chapter 1. Plus 4 times x is negative 2 again, plus 7. Order of operations, exponents go first. Multiplication comes next. Adding and subtracting goes from left to right, just like we read. You get negative 4 plus 7. 3 does equal 3. Please do not use the does not equal sign. 3 does equal 3, so therefore we circle yes. Ta-da! Chapter 3, section 1, question 3. We're going to work on t-tables. T-tables, this x and y table here, often people just write this part here, which is why it's called a t-table. Now, I'm not going to draw the line all the way down. We could take every single one of these numbers from negative 6 to positive 6 because my x-axis has all the numbers from negative 6 to positive 6. But I like to work smarter, not harder. This equation here has a divide by 3. So as I'm plugging it in, if I have negative 2/3, I plug in a 6 plus 1. I can divide by 3, and that will give me 2 times negative 2 is negative 4 plus 1 is negative 3. That is an ordered pair that I will graph on my graph soon. Then, 5 does not divide nicely by 3. 4 does not divide nicely by 3, but 3 divides nicely by 3. 3 divided by 3 is 1 times negative 2 is negative 2 plus 1 is negative 1. 2 doesn't divide nicely by 3, 1 doesn't divide nicely by 3, and a lot of students get messed up on the 0 work. Folks, 0 is the most amazing number to plug in, because in chapter 1 we learned about the multiplicative property of 0. 0 times anything is 0. So 0 plus 1 by the additive identity is 1. Now, in math there are often patterns, so let's take a look. Did divide by 3, did not, did divided by 3. Oh, 1, 2, 3, hey. 1, 2, 3, hey. 1, 2, 3, hey. That's the next one that's going to divide nicely by 3. And we're going to get y equals negative 2/3 times negative 3 plus 1. Negative times negative is positive. 3 divided by 3 is 1. So I get 2 plus 1 is 3. All right, there are more patterns because we can still go 1, 2, 3. This one is going to work, but let's now look at these numbers. Negative 3, it went up 2, it went up 2, it went up 2. So this one is going to go up 2. This is going to be 5. Math is all about patterns. Patterns are amazing. Now we're going to graph these. X is positive 6, y is negative 3, make a dot. 3, negative 1, make a dot. 0, 1, make a dot. Negative 3, 3, make a dot. And negative 6, 5, make a dot. I want to see all of these points graphed. Point is the official word for dots. And then, we have a straight edge, and I'm going to check. Yes, I can hit that dot with my pen. Yes, I can hit that dot with my pen. And I'll hold on to it very tightly and run along the edge of it. Oops, it moved a tiny bit. So maybe I will erase this part here, put my point back there, and I'll redo that last little bit there. All right, nice straight line through the points from my T-table. Arrows at both ends, slightly past the edges, arrows at both ends. That's how you're going to graph a line. I have seen some students, they don't put these points here, and I've also seen some students who only put 2 points and then they put their arrows and they're like, well, that's all I can do. Folks, if that's all you can do, you're not going to get full credit. I want to see as far as you can go on the graph you've been given. Chapter 3, Section 1, Question 4. This says graph each equation. Now, when I have you graph an equation, it's going to be either one or the other. At this point in math, we are not yet going to have you put 2 of them on the same piece of graph paper. But for the purposes of this slide, I have 2 of them. So instead of starting at one side or the other and plugging in everything, I want to start in the center. And we're going to start off with y equals negative x squared plus 1. This is a quadratic formula because it has the 2 as the degree. This is also going to make the shape of a parabola, which is going to be kind of a U-shaped graph. So here, we're going to take, instead of x, we're going to use our plugging skills from back in chapter 1 and 2. Plug in exponents first using our order of operations, times it by a negative, and then add 1, we will get 1. Then we'll go to the next number, and we have plugging it in, and then exponents first, multiplication second, and addition and subtraction last. We get 1, negative 1 plus 1 is 0. Plugging in the next number, order of operations, 4, negative 4 plus 1 is negative 3. Next number, ooh, not that, that's the last number. There we go. 9, negative 9 plus 1 is negative 8. That is going to go so low, it's going to go off the bottom of our graph. So we don't actually want to have that one. Well, we do want to have this one because we're going to want to see where it goes. Then we're going to start going the other direction. At this point in math, right now, the x squared, the parabola, and the absolute value of x, which is going to make a V-shaped graph, those are just going to, once you find out where the top or bottom is, it's just going to keep going in those directions. Later on, we will have graphs that you'll have to keep testing things out because it's going to zigzag along there. Here we go. We are plugging in a negative 1. Exponents first, that's 1. Multiplication second, that's negative 1 plus 1 is 0. I see a pattern again. Ooh, there's patterns in math. Here, we have a little sideways happy face. That's 0 and that's 0. We're going to try another one. 4. Negative 4 plus 1 is negative 3. Oh my gosh, my pattern still works. Do be careful trying to define a pattern before you have enough information. Once you've done enough parabolas, you will see that these really do go in this kind of a pattern. So here I have 0, 1, and then 1, 0, and negative 1, 0. 2, negative 3, and negative 2, negative 3. And then at 3 it goes down to negative 8. I'm actually going to make an estimated dot down here because I want to know where my graph is going. Now, you see parabolas all over the place if you ever run off of a diving board and dive. So here we have a diving board and they're going to go, ah! And that is how they're going to hit all of those points. I do have some students who they get off of their diving board and they use a straight edge and they use a straight edge and then they use a straight edge, and that is not how people dive off of a diving board. So obviously they would need to go swimming some more. And so they might start off okay, but then I've seen some students who also do this. That is not how it goes. You are not caught by a sudden gust of wind. I have seen some people do this. That's not how it goes either. And then I've seen some people who go straight down the line. That is also not correct, which is why this dot here that's off the graph, I think is important because it helps you to see where you go. Maybe my estimate was off by a little bit. But that is the U-shaped parabola graph. We're going to get into this a lot more in chapter 8. And what we're going to see there is negative. It's upside down. And it opens downward like a frown. The x squared is going to determine the pattern of how our dots are drawn. And then the plus 1 says it starts here at 1. And then 1 squared is 1. Counting from the vertex, which is its top point or bottom point, you count 1, 2. 2 squared is 4. 1, 2, 3, 4. From here, 3. 1, 2, 3. 3 squared is 9. We count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how we get to that last point there. Eventually, we won't have to use the t-tables, but the reason that we're teaching you the t-tables now is they always work. So this is a way that even if you forget the tricks that we show you, you can still get the graph in a future math class. Don't forget the other equation. We have y equals negative absolute value of x plus 1. We're again going to start in the center at 0. Y equals negative absolute value of 0 plus 1. We like starting up at 0 because it's a very nice number to plug in. The absolute value of 0 is 0. There is no negative 0, so it's still 0 plus 1 is 1. Hey, we like positive numbers. In fact, positive numbers with absolute values work out very nicely. That gives me 1, negative 1 plus 1. Oh, that's 0. Plugging in a 2. Absolute value of 2 is 2. Negative 2 plus 1 is negative 1. Negative 3 plus 1 is negative 2. Hey, I feel like I'm starting to see a pattern here. 4, negative 4 plus 1 is negative 3. It goes 0, negative 1, negative 2, negative 3. It's going to go negative 4, negative 5. Now let's go in the other direction. This one gave us a 1. And then y equals negative absolute value of negative 1 plus 1. Absolute value of negative 1 is 1 times negative. Negative 1 plus 1 is 0. Ooh, just like the parabolas, I am starting to see the pattern. Yay. Y equals negative absolute value of negative 2 plus 1. 2, negative 2 plus 1 is negative 1. Ooh, I am seeing my pattern working. Yay! I'm thinking that the pattern is going to continue going on for the rest of these. So that's going to be negative 2, negative 3, negative 4, and negative 5. All right. So graphing this out, plotting those points. It's going in an upside down V because that was a negative absolute value graph. Working our way outwards. Notice that this is going to make a line with a slope of either positive 1 or negative 1. And then, because it's making a line with a hook in it, we're going to use a straight edge. Now, the important thing when you're using the straight edge is don't go past this top point here. What we don't want to do is make a little X here at the top. We're just going to take it from that top point called the vertex, down and out, past the edge of the graph, and then arrows at both ends. That is an absolute value graph. Now, this is a negative absolute value graph, which is why it's down that way. If it was a positive absolute value graph, it would make a V for value. Chapter 3, Section 1, Question 5, Type 1 of 2. Hey, that's not normal. We are used to seeing equations that have a y equals. We select the x numbers and plug them in. This is an x equals, so we select the y numbers plug them in, and that will go backwards and find us x. So whichever letter is on the yucky side, that's the one we're picking. All right. We're again going to start in the center. It says x equals y squared minus 4. X is equal to y squared minus 4. We're going to plug in that y is 0. 0 squared is 0, minus 4. Exponents first, adding, subtracting second. Hey, that's an ordered pair on our graph. Exponents first, adding, subtracting second. 1 minus 4 is negative 3. Exponents first, adding, subtracting second. 4 minus 4 is 0. Nine minus 4 is 5. Sixteen minus 4 is 12. That is off of my graph, so I'm going to stop there, and we're going to go on this way. 1 minus 4 is negative 3. I'm seeing my pattern again. This time the pattern is on this side. Let's do a little bit more just to make sure that the pattern is correct. But since this is a y squared, we've had x squared before, that was a parabola that had this pattern. I suspect that this one is going to be a parabola. But it's going to be changed a little bit, and we're going to see how that happens. 4 minus 4 is 0. It does work, so this is a 5, and this is a 12. So we're going to graph these. We have 0, negative 4. And then negative 3, 1. Actually, that's negative 4, 0. Negative 3, positive 1. Negative 3, negative 1. 0, positive 2. And 0, negative 2. 3, nope, 5 and positive 3. 5 and negative 3. And 12 would be way over there. I feel like we're close enough to the edge of the graph. We're going to have to fall sideways. All right. Here we go. That's how it goes, slightly past the edge, and arrow at the end. Slightly past the edge, arrow at the end. Please do not actually scream during a quiz or test in class. Please do not actually scream in your college class.